Hi, good morning. In mathematics, the absolute value or module of a real number x is denoted as absolute value x. The x is the non-negative value without regard to its sign, namely absolute value of x equal, you have two choices. The first choice, absolute value of x equal x if x superior or equal 0. The second option, minus x if x strictly inferior than 0. Let's put f of x equal absolute value of x as an example and put in the graph to see how this absolute value involved in the graph to understand the conception of absolute value, what absolute value means, okay, in this case. So as you see here in your function, so as you go up, as the numbers go up towards infinity, 0, 1, 2, and so on, you see the image of these numbers are positive. You see, f of 1 equal 1, f of 2 equal 2, as you see here. As you go to in negative direction, minus 1, minus 2, and towards minus infinity, so you are going to the negative numbers on the other direction. So as your negative numbers going down, you see the image of these numbers are always positive also. You see, f of minus 1 equal 1, f of minus 2 equal 2. So your function is decreasing, okay, and then we get to 0, f of 0 equals 0, and then start again going up, is increasing. This is decreasing from minus infinity to 0 and increasing from 0. That's not the important thing. The important thing, we are looking for the positivity of absolute value, okay, as you see here. So absolute value of x is always positive, including 0. The 0, f of 0 equals 0. Let's move on to the next example to see how this absolute value works here, to understand the conceptions very well. So let's put the next example, f of x, okay, f of x equals square root of x square. So always when you take the number out of square root, you have to do the absolute value, okay, because to keep the numbers positive, because they coming from square root. So in this case you have two choices. The first choice, this one equal x if x superior or equal 0. You have minus x if x strictly inferior than 0, okay. This is what it is, okay. This is your example. Why you put this one x and minus x? Because we don't know your number. It may positive or negative. It came from the square root. We don't know the number. It was positive when it was in the side of the square root or negative. So that's why you put two options. As you have, if you have the positive number, is always put x. If you have a negative numbers, you put minus x in order to get the term positive. Because negative, if this one is minus 1 multiplied by minus 1 equal 1, okay. Because that's why you put, if your x is negative, and then you put a sign negative to become positive. If it's positive, you put then the sign positive, your term become positive. That's the reason why we put minus here. You have two choices, because we don't know the number is a positive or negative. Let's assume, take an example to understand this very well. Let's assume x equal 3, right? So square root of 3 square, which is 9, right? So it's an absolute value of 3, which is 3. Okay, let's assume, let's take this assumption like square root of minus 3 square is also 9. That's what I want to show you, because the square of negative number is always positive. That's the reason why I'm doing this one. So this one, to make it very clear, you have minus 1 square and 3 square. The minus 1 squared is a positive, because minus 1 multiplied by minus 1 equal plus 1. Okay, that's the reason why this is square. Square, that's mean double. This one you square it. Okay, it's not a double 2 times, but it's square. That's mean the same number multiply in the itself in the same number. Okay, which is 1. So this one is become 3 square, become absolute value of 3. That's mean 3. Both results are the same. Whether you have a negative number inside of the root or positive inside of the root, at the end when you take your number out of square root, it become positive number. So you have positive number. Okay, so let's move on to the second example to understand this one more good. Okay, let's put, for example, f of x equal square root of x squared minus 2x plus 1. Okay, this one, if you factor this one, this is quadratic form, quaternary square 2, which is x minus 1 becomes 1. Okay, always put absolute value. Do not forget absolute value, because we don't know this number, it was positive or negative. Okay, that's what I was explaining here. So always you have 2 choices as long as you don't know the number. Okay, so equal x minus 1 is 1 if x minus 1 it was positive. Always put 1 superior or equal 0. The second term puts strictly inferior than 0. You put only one term, which one is included 0. Okay, not both of them, because kind of repetition. Do not put it twice. Okay, always put 1 x superior or equal 0. Second one put x strictly inferior than 0, because here that's mean 0 is included. F of 0 equals 0. Okay, so x minus 1 if this is minus negative sign in the front, do not forget it. Okay, if this term which is x minus 1 inferior, strictly inferior than 0, if this one negative, you have to put the sign negative in order to get a positive number. That's it. Okay, this one gives you this one absolute value because it's always positive. Okay, this is for real numbers. When I'm talking about the real numbers, that's when I'm talking the other sets like the n integers number, the other groups. Okay, the real numbers is included everything, all the sets, but except the complex number. We are going to see it later. To see the minus 1 is involved, you can put it inside of the square root. This is not our topic now, so we will talk about that later on. So let's move on to the final example. F of x equal, for example, x, if you have this term x minus 1, x plus 1 inside of the root. Okay, if you put this one, let's distribute this one, gives you x squared plus x minus 1. So, well, okay, yeah, this one x square minus 1. This one, you are leaving it like this because this is not square root to take it out, okay? You will leave it like this. And then also, you have domain range, you have this one, but you have a condition, you have x square minus 1. You have to keep it positive, okay? This is your condition. You cannot take it out. I'm doing this example to show you, you cannot take any number. You have to square it to take it in order to take it out, okay, of the square root. This one is stay like this, but with this condition. This has to be positive, okay? It has to be positive. Okay? If you want to take this one to make sure where is the x, okay? So let's put as a graph, like the table, put the numbers x, you have minus 1 and 1. This is the roots of this function, okay? So this one, put positive, negative, positive. These are positive numbers, you see, as you see here, positive, positive. This is negative. So x belongs to minus infinity, minus 1, okay? Minus 1 is included, okay? You have 1 plus infinity, union 1 plus infinity, okay? This is what it is, okay? So your x is this interval, okay? X from this interval. You can, because then if you put the number, for example, 0 between minus 1 and 1, right? Let's put a 0 here. If you put f of 0 equals 0 minus 1 equals minus 1, which is restricted to put this number here. Impossible, okay? That's what I'm showing you here. So your x, you have to put in this condition, okay? I think everything is clear and enough and clear. Thank you for watching. I see you in next video. Bye.